Okay, here we go. Now we're to shop job 2302, and this is going to have the same functionality as 2301 did with a few changes. So we're going to come here and look at the list of inputs, and I am now going to have jog functionality based on a third push button. Okay, so the what is normally the yellow push button will be a jog push button, and the green will only be a start push button. And then we're going to need a reset function because we're going to have a counter on this one that's going to count our motor starts. So we're going to use the 2-position selector switch to reset. And then the blue light implementation is going to be just a little bit different. We don't have a selector switch for jog, and we can't tell the operator ahead of time that they're going to be jogging. They hopefully will know that when they push on the yellow push button, but the blue light will come on only when the motor is running. So those are going to be our three main differences. Let's go over and look at 2301 and convert it to 2302. So we're going to save this as 2302. And I believe I already have one there, but we'll just overwrite it. Okay, we'll change this to 2302. Okay, so I'm going to maximize this so we can see it. And move this over. Okay, so now first thing is we know that we don't have a selector switch for our jog functionality, so we're going to remove that. And we're going to have multiple things that are going to drive our output. We're going to have our rung for our run, and we're going to have a separate rung for jog. And since we have two things that drive one output, we're going to have to use binaries. So I'm going to come up here, and I'm going to substitute my output address for a binary address, B3:0.0. Okay, and when we only have one direction, we typically call that forward. So I am going to call this run forward command, and it'll be beneficial when we get into reversing that I've already called this one forward. Okay, so it's going to be run FWD. Okay, and then that binary will also replace that output address that we have down here in the holding circuit. So the only way that we're going to hold ourselves in is if we were the ones that drove it to run forward. Okay, so that's all of the changes that we need in rung 0 for changing from the previous job. If I come out here and give focus to that rung, I'm going to hit Control C, then Control V to copy it. We'll go ahead and get rid of our description here. And we know from previous jobs that the difference between run and jog is that we don't have this holding circuit in here. And of course we want to change this to our jog push button. And so we're going to put the assignment of 6. I'm going to show that here. This yellow push button here is going to be 0.0/6. That's where I got that from. Okay. So we need to rename this, and this is going to be our jog push button. Okay. Okay. So now we have all the functionality that we need. Of course, we want to include these other things in our jog rung. If E-stop is pressed, we don't want to jog the motor. If someone by chance is holding down the stop push button and the jog push button, we don't want to invoke the motor. And of course, if we're in an overload condition, we don't want to jog the motor either. Now, this is actually our run forward command, and we actually want to assign a new binary here, and this is going to be our jog forward command. Okay, and I'm just going to symbolize this by JOG FWD. Okay. All right, so we have some binaries established. We need to write those to the outputs lower in the program. And again, I usually put all of the decisions that need to be made at the top of the program for whatever final control element that we're controlling. And then I write all the outputs down at the bottom. And in the bottom, I always put the outputs in their address order. Makes it easier to find and makes the program rather organized. Okay, so I am going to put focus on my blue light here, and we are going to insert a rung to actually energize our output, and we want to energize O:0.0/3. Okay, so that's my motor starter. And that's going to be in this particular panel, this motor starter right here to the right. And what we want to send there is one of two options that have been selected. One of them is going to be my B3:0/0, my run command, or whenever I say or, that means parallel, so I need a rung branch. And I'm going to put the rung branch below that, or we could say it's going to be B3:0/1. So, and that says or jog forward. So if I'm telling it to run forward or jog forward, I'm going to turn this thing on. The difference is one of those has a holding circuit in it and the other one does not. Okay. We were able to accomplish this before in manual motor controls because we had a dual action push button, but we didn't wire up the yellow push button as a dual action. We just wired it with one input because it was unnecessary in a PLC. We can examine if open and examine if closed on one set of inputs. So we have our run forward and our jog forward commands ready to go. We have our implementation for our yellow light, which did not change. Our implementation for jogging has changed. Okay, so we're going to get rid of this. Our selector switch no longer determines jog. And we're going to need a couple instructions here. The first thing we're going to need to test is if somebody is pushing on that jog push button. Okay. Now, just because we push on the jog push button doesn't mean that we want the jog light to come on. We want it to come on when they're pushing on it and the motor actually started. Okay, so we want to come here and we want to go to that set of status contacts. If we push the button and those status contacts come back, then we will turn on the blue light. Okay, so now we have our jog functionality and the blue light indicating that functionality. Now all we have to do is set up our counter. So we still want to count the times that this set of contacts closes. So I'm going to come here and I'm just going to hit the delete key to get rid of that instruction. And I'm going to come up here to my counter timer tab and select that. And then we want to select count up. Okay. Counters use a different register than timers. It's the C5. And the very first one is just going to be C50, and we're going to call this our motor start counter. Okay. And I'm going to call this MTR space CTR. Okay, motor counter. And in a counter, it differs from a timer. A timer, once you get to the preset, it stops timing. A counter, when you get to the preset, it'll set the done bit. But if you continue to have motor starts, it will continue to count. So we don't necessarily have to put a preset in here. In my description, I don't tell us to do anything after so many counts. So we're just going to leave that at 0 for now, just so we can understand the operation of the counter. In a future lesson, we'll get into counting to a fixed number and then having something happen based on that count. All right, so this jog push button is not going to reset our timer. What is going to be our 2-position selector switch. I'm going to head back to our shop job here, and we have a reset based on this 2-position selector switch, and I want the B position to be reset and the A position to mean count. So here, the B position on the 2-position selector switch is open. Okay, so if we want B to reset, we want to examine if open. I'm going to come back here and use my examine if open instruction. And this will be the selector switch, I:0.0/3. Okay. Previously that was our mode. Now it's going to be our counter reset. Okay. And let's be a little more specific. It's going to be our motor counter reset. Okay. And then here, this reset operation can reset timers or counters. In our case, we want it to reset a counter. Okay. So now if we put the selector switch in the B position, this will evaluate to true, and it'll reset our counter, and we'll start counting from 0. Okay, so I'm going to go ahead and download this, and we'll give it a shot. So we're going to come up to the top here, and the first thing I'm going to do is I'm going to push my what would normally be the green push button, and see that our start operation works. And you can see up here that it's a little hard to tell, but that moved, and we have our control relay for our lights that changed our light status, and we can also see that we're holding because we were the ones that invoked the starting of the motor, and the control relay pulled in. Okay, so that looks good. And we're also going to come down and check our counter. And this closed. Anytime this closes or a transition from false to true on this rung, we're going to count 1. So we actually have an accumulated value of 1. Okay, let's go ahead and hit stop. And now I'm going to hit our jog button, and you're going to notice a couple things. Number 1, we're going to get a closed contact right here, but because we didn't push the button to invoke our run forward binary, we're not going to have a holding circuit here. We're just going to have our jog circuit. And let's go down and look at our blue light implementation. So on the blue light, if I push on the jog button and the motor actually closes, then we're going to turn on our blue light. Okay, and you can even see down here the 2 things that can actually start the motor. One is that jog forward binary, and then I'm going to go ahead and hit the start button here, and it's that start button. Now you can see why the blue light isn't coming on is because I'm not pushing on that blue light binary. Okay. And we have started the motor a grand total of 9 times. So now what we want to do is test our reset and our overload. So let's test the overload first. So I'm going to come up here so we can see the overload take effect. Okay, so when I pushed on that button, it closed the set of contacts. This is an examine if open, so that was no longer evaluating to true. It broke my holding circuit and turned my binary off, which in turn drove or reset my output. So now let's reset our counter here. Okay, so I'm going to put the focus on the end here, and we have a grand total of 9 starts. I'm going to push the jog button just to make it an even 10. You can see it. You can see it actually increment there as I start the motor. Now I'm going to go ahead and flip our 2-position selector switch over to the B position. And in doing so, you see that the accumulated value here was reset to 0. Now, here's something that's important to note. If I leave it in that position and I start the motor, I'm not stopping my motor from running, but I am not counting. Okay, so that's something that you have to be careful of when you're using a non-momentary type input device to do a reset function. So now when I put it back to the A position, now it's going to begin counting. Okay. All right. So that is Shop Job 2302. I hope that helps, and we'll see you in the next lesson.